Hi everyone, this is going to be our last video on graph sketching and analyzing f prime. So it's just meant to be a review video. I know the videos have been running a bit long lately, so I'm going to do my best to kind of go through this fairly quickly. We'll see how much success I have with that. So the first thing we're going to do is just go back to where we started. If we have the graph of f of x, and we're going to talk about finding critical points, increasing, decreasing, concave up, concave down. So having the graph of f of x is obviously the easiest case to deal with. So when we're talking about critical points, remember that's where f prime of x is equal to 0 or it's undefined. So that means if I'm looking at the graph of f of x, f prime of x is going to be 0 wherever I have a horizontal tangent. So in that case, it's going to be here. I have a horizontal tangent here and here. So at my critical points are going to be x equals -1 and x equals 1. Now, for my maximum values, right, I'm looking for the highest point in an interval. Now again, I'm going to assume that this has kind of infinite end behavior here. So for my maximum, I'm going to have a relative max at x equals -1, because that's the highest in that kind of local interval. I'm going to have a minimum value at x equals 1. And again, it's the lowest in that value. And so it's worth noting here that because of this end behavior, I'm going to have no absolute max or min. So now we know we're increasing wherever the graph of f has a positive slope. So wherever f prime is greater than 0, so I'm going to have a positive slope over these two intervals. So I'm increasing from -infinity to -1. Remember, we used closed brackets here. And then I'm increasing again from 1 to positive infinity. And so then I'm decreasing wherever f has a negative slope. So from here to here. So I'm going to be decreasing then between -1 and 1. So now the last thing we're going to talk about is concavity. So I am going to be concave up. Let's see, I don't know if I have another color here. I'm concave up everywhere my second derivative is greater than 0. And so we know we're concave up wherever we look kind of like a cup, wherever we would hold water. So if I'm looking at this graph, I'm going to be concave up over this interval. And so from 0 to infinity, I'm concave up. And remember, concavity, we use, open intervals. And then I'm concave down, like a frown, from -infinity to 0. And so what I notice is that at x equals 0, I change concavity, so my inflection point happens at x equals 0. So that was the most basic scenario where we're given the graph of f. So from there we moved on, and instead of being given the graph, we were given the function for, or the equation of our function, So we still had to answer all the same questions. And so we started out by looking at our critical points. And again, we know that's where the derivative is equal to 0 or it's undefined. So the first thing we did was calculated our derivative. So -3x squared plus 6x. I know that's never going to be undefined, so I'm just going to find where it's equal to 0. So I'm going to go ahead and factor out a -3x, and then I get x minus 2 is equal to 0. So I'm going to have critical points at x equals 0 and x equals 2. Now, for my points of inflection, we dealt with the second derivative. So we're going to calculate our second derivative, -6x plus 6. Again, that's not going to be undefined, so we're just concerned with where it's equal to 0. If I factor out a -6, get -6 times x minus 1 is equal to 0. So I have a possible inflection point at x equals 1. And again, we say it's only possible because we don't know that the concavity actually changes there. So for now, it's just a possible point of inflection. So I'm not going to put it down quite yet. So now we went ahead and we made our table. And so I have my first derivative and my second derivative. And now at the very end, I'm going to have negative infinity. Then I have my first critical point, x is 0. I have a point of inflection in between there. I have another critical point, and then at the end I have infinity. And so now I'm going to test my intervals. Now, we're going to first look at y prime to figure out where I'm increasing and decreasing. Oops, sorry, this is crooked. I should have checked that. So for that, I'm going to go to my first derivative. And so now I have critical points at 0 and 2, so I only need to check 3 intervals. I need to check for less than 0, I need to check in between 0 and 2, and then anything greater than 2. I'll put infinity here. So first we're going to plug in, let's say, a negative 1. So if I plug in a negative 1, negative 3 times a negative 1 is positive. Negative 1 minus 2 is going to give me a negative, so I'm going to be negative or decreasing on that interval. Now, like I said here, I'm not going to test a point between 0, 1, and 1 and 2. Since my critical points are just 0 and 2, I only need to test one point in between those, and I can get my value for both of these spaces. So I'm going to test 1, because that's the easiest. So negative 3 times 1 is going to give me a negative. 1 minus 2 is also a negative, so that's going to give me a positive over this interval. And then last but not least, I'll pick something greater than 2, so I'll pick 3. Negative 3 times positive 3, that's going to be negative. 3 minus 2 is 1, is a positive, and a negative times a positive is a negative. So now I have my information on increasing and decreasing. So I'm increasing from 0 to 2. Again, I'm using closed intervals. And I'm decreasing from negative infinity to 0, and then again from 2 to infinity. So now, looking at my second derivative, since my only possible point of inflection was at x equals 1, I just need to test one point that's less than 1 and one point that's greater. So I'm going to plug in 0. If I do that, I get a negative times a negative, which is a positive. So I'm going to be concave up. If I plug in, say, a positive 2, now I have a negative times a positive, so I'm going to be negative or concave down. So now I have my intervals for concavity. Concave up is from negative infinity to 1, and concave down is from 1 to infinity. And now I look over here at x equals 1, I changed from concave up to concave down. So since that concavity changed, I can say I have a point of inflection at x equals 1. So now if I'm going to sketch it, I just need to give myself some y values so I know where to place my graph. So let's get the y values of these points. If I plug in 0 into the original equation, my y value is just going to be 0. If I plug in 1, I get a negative 1 plus 3 gives me a positive 2. And then if I plug in 2, let's see, 2 cubed is 8, negative 8 plus 12 is going to give me 4. Hopefully I did that correct. So now I have everything I need to go ahead and actually sketch this graph. So before I put it on my coordinate plane, I just want to take a quick look at this behavior. So I know it should be down and concave up, and then increasing and concave up. I turn to increasing and concave down, and then decreasing and concave down. So I expect this kind of shape. So let's go ahead here on our coordinate plane. My x, I guess I could have ignored the negatives there. I have 0, and then 1, and 2. I know at 0, my point is 0, 0. At 1, it's 1, 2. And then 2, I should have left myself a lot more room here. Sorry about that. We're just going to go up Here's 4, and here's my 0.24. Now, I know that I'm going to have a minimum value at x equals 0 because I'm changing from decreasing to increasing. So I'm coming down here, so I have a minimum there. I'm going to go up. At 1, I don't have a max or a min. So I know I'm just changing concavity there. So I'm concave up. Now I know I have to change to concave down. And then again, I'm going from positive to negative, so I'm going to have a max at x equals 2. So I know my graph should look something like that. And again, I'm not concerned about where this x-intercept is. I just want that basic shape with those critical points and point of inflection. So the last piece of this then was answering these questions if we're given a graph of f prime. So here we go. So for our extrema, we want to know where our maximum and minimum values are. So let's look for the max. And just like we said before, we know the max values occur where f prime changes from positive to negative. And again, if I'm looking at a graph of f prime, I change from positive to negative wherever I cross the x-axis, where I go from being, above to below the x-axis. So I'm going to have a value here at x equals 0.5. And then again, I go from being above to below at x equals 3. And here we're on this open interval. I don't have endpoints here, so I don't have to worry about considering those endpoints. For my minimum values, I know this is going to occur where f prime changes from negative to positive. So now I'm looking at where the graph goes from below to above the x-axis. So I change from below to above here at x equals 2. So those are my extreme values. Now, increasing is where f prime is greater than or equal to 0. So where am I above the x-axis? So I am above the x-axis from negative infinity to 0.5, and I'm above the x-axis from 2 to 3. Decreasing, we know, is where f prime is less than or equal to 0, or where I'm below the x-axis, which is going to occur here from 0.5 to 2, and then again from 3 to infinity. So now we look at concavity. So I'm concave up wherever f double prime is greater than 0, which means I'm really looking for where the slope of f prime is positive. So the slope of my graph, I have a positive slope from here up to about here. So if we estimate that, it looks about maybe, 1.3 up to about 2.4. And again, I'm not as concerned about those values as do we know where that occurs. And then on the other hand, I'm concave down where f double prime is less than 0. So where is the slope of f prime negative? So I can see pretty easily here. I'm going to be concave down from negative infinity to what I called 1.3. And then again, on this interval here, I called that 2.4 to infinity. So now it's easy to see where my points of inflection are, right? And we know those were potentially where f double prime is equal to 0, which on our graph we're just looking for those horizontal tangents. And I'm also going to make the note, it's where f prime is equal to 0 and concavity changes. So in our case, those points are going to happen. I change from concave down to concave up at 1.3, and I also notice I have a horizontal tangent there. So at 1.3, and then I change again from concave up to concave down and have a horizontal tangent here at 2.4. So that's how we get our information from the graph of f prime. So that's it for this graph sketching section. We'll do a little more practice with it before moving on.